Factoring by grouping is, again, what we've been doing above. And I want to show you an example of numeric uses of this. 6 times 2, actually, you know what, here, I'm going to do this. 2 times 6 plus 4 times 6. Okay? 2 times 6 plus 4 times 6. You might say, okay, that's 12, and that's 24, and end up with 36, right? Most of you would do it that way. But another thing to recognize is that both of these terms are being multiplied by the same thing. Just like the previous day's examples, both of these terms are being multiplied by the same thing. So instead of performing the distribution and then combining, if you were going backwards, you group and then you make them both be multiplied by that item they were sharing as a factor anyway. So this is the shared factor of both of them, right? So 6 times the sum of those two factors, how about 2 and 4, 24, 34, and you end up with 36, okay? Now maybe your mind doesn't work that way, but the reason I'm showing this to you is so that you understand that this is all we're learning today. If there's a shared factor, list it one time and combine the items that are being added together separately. So it looks just like that, only there's multiple pieces here, obviously. Okay, that's what we're going to be working on today. Starting with example 1. We've got 5 times x plus y added to w times x plus y. Is there a shared factor? X plus y. List it one time. Okay, list it one time. And then the other two things get combined. You've already been doing this with yesterday and the previous days, okay? So if there is a shared factor, list it once, and then combine what is left in the other parentheses. Okay? Letter B does the exact same thing, only it's a little bit tricky. You're going to say m plus 4n m plus 4n. Well, what is here that is being carried over this? There's nothing here. So you might say, well, m times m plus 4n then. No. Since there is nothing here, you insert a 1. Okay? Because that 1 is what is being multiplied over these two pieces. That negative symbol is what's being multiplied by over those pieces. So you have to have that 1. So m minus 1, sharing the factor m plus 4n. Okay? This is probably one of the easiest things to forget when you see that there is nothing there. Just a symbol. Insert a 1. Okay? Shared factors, shared factors. All right? So you've seen that. Example 2 gives us times when they don't quite match, or they don't appear to match. Let me put it that way. So example 2 is 5a minus 3 minus 2a. 3 minus a. Does everybody see that? We've got this and this, but these two are opposites of each other. Okay, this is the opposite of this. Negative 3, positive 3. Those are opposites. Positive a, negative a. Those are opposites. Okay? In order to make these match, I must invert and create a negative 3 and a positive a. Or in contrast, flip those signs. And the only way I can do that is instead of having a negative 2 here, flip the sign of this and that then flips the sign of these. Okay? So instead of factoring out the negative 2a and having a positive 3 and a negative a, I invert the sign of this, and in order to keep things the same, the signs must be flipped. Okay? Think about it. Originally, it was negative 2 times positive 3a, and if I distributed it, I would have had a negative 6a, right? And it was a negative 2 and a negative a, and if I distributed that, I would have had a positive 2a squared, right? That's the original. Since I flipped the signs, I now have positive 2a times negative 3, negative 6a, positive 2a times positive a squared. Okay, again, just by flipping the signs, I am still able to produce the same product when I distribute. Okay? Now the reason I'm showing you that is you're going to need to do that in order to factor by grouping. I can now group my 5 plus 2a by a minus 3. A minus 3. Okay? This is going to be the one opportunity that you're going to go, oh, it's prime. No, it's not. Flip the sign to make things match. Okay. They're not always going to give you this all neatly set up. Example 3. 2ab minus 6ac plus 3b, shoot, lost my place, minus 9c. Okay, there's 4 items in this polynomial. I don't see any like squares or anything really that I'm used to seeing in my old patterns. And then no pattern, 3 pieces. Well, this is 4 pieces. I don't know what to do. Well, when you guys had created 4 pieces here, you then grouped and factored, right? That's what we're going to do here. We're going to look at this and see if there's any way I can group anything together. And if you need to move stuff around, you can. Okay? Like if I think this has a lot in common with this, I'll group those together and then factor. But I don't. I believe the way it is currently grouped is probably the best way to do it. What can I pull out of both of these? 2a. B minus 3c. Let's hope I end up with the same thing. What can I pull out of here? 3, positive 3. B minus 3c. And now I have exactly what we've had the past few days. Combine 2a plus 3 and multiply them by the shared factor, which was b minus 3c. Okay? What if I had this listed this way? I flipped everything around. Just change the order. Does that mean it's not factorable now? Does that mean it's prime? What do you do, Jared? You move them until you can find relationships. Like I would group this with this. Negative 6ac plus 2ab. It doesn't make a difference, the order. Okay, so I've just grouped those two together. Negative 9c plus 3b. Okay? I did them in a different order on purpose so that you could see that it doesn't make a difference in the end. Now that I've grouped them with partners that seem to match one another, let's see what I pull out here. This and this. Now, I could pull out a negative 2a, but I'm thinking that that's going to result in me having to flip a sign somewhere. So I'm going to look at this and I'm just going to try a positive 2a. 2a, negative 3c plus b. Out of here, I'm going to do, I could try the -3, but again, I might have a sign problem, so I always try to keep everything positive when I pull stuff out if I can. +3, -3, C plus B. 2A, shoot, I didn't write it. 2A plus 3 are both being multiplied by -3C plus B. Isn't that the exact same thing as the thing above? 2A plus 3 is the same as 2A plus 3. -3C plus B is the same as B -3C. Okay? So if you ended up in doing it this way, like let's say they didn't have it grouped neatly for you, and you came up with this answer, it would still be correct. So don't ever think if you look in the back of the book, if the book says B minus 3C instead of that you've got it wrong. You don't. You're not wrong. All right? They give you another way of looking at it in solution 2. We're not going to go over that again. Example 4. Here's the toughest one of the bunch, people, which is why I've been hammering you guys with the patterns. Example 4, we've got 2AB minus 6AC plus 3B minus 9C. Do you guys all see that sitting there, all organized together?
I'm switching.
We've got these two items here. What can we group together? Well, when I look at this, shoot, I just wrote the same thing from above, guys. 4p squared minus 4q squared plus 4qr minus r squared. Okay, so now I have the thing all set up. Okay, wonderful. Well, what if I look for a pattern in this mess? Are there any difference of squares? Are there any perfect squares? Well, if I group these two together, I actually have a difference of squares. 4p squared minus r squared. But then what am I going to do with this? Not really sure. I would rather look for a 3 grouping that I could easily factor out. This one here is a perfect, or hold on, let me leave it like this, is going to become a perfect square when I factor out the negative. Okay? If I factor this negative out, so instead of being a -4, it is a positive 4q squared. Instead of being a positive 4, it is a negative 4qr. Instead of being a negative r, it is a positive r squared. Bring down the original item. Now, the reason I know this is true is if I multiply this back over this, I get what's above. Negative times positive, I get that. Negative times negative, I do indeed get that. Negative times positive. So I have pulled out correctly. So in effect, I pulled out a -1 if you get my drift. Okay? So perfect square factors. So this would be 2q. And this one is going to be minus r. Twice the product of that. Will I get that? Yes, as long as that's a negative. So now this is the factor for the right-hand side. This still needs some work. Okay? What else can we do? Well, this is the difference of 2 squares. That's a perfect square, square root of which is 4p. That's a perfect square, see? Square root of this is 2q minus r. So if I separate by a positive and a negative, I have my answer. Square root of this, 2p. Square root of that, 2q minus r. Oops, that should be an r. 2q minus r. There's your answer. You don't realize that this difference of squares here simply gets broken up. Square root here, plus, minus. Square root here, and here. Okay, here's the plus, here's the minus. Difference of square pattern, just looks a little bit differently. This is the piece that's known as A. This is the piece known as B. This is the piece known as A. This is the piece known as B. A plus B, A minus B. Now, is there anything else I can pull out of these three? No. Those three, no. You are now simplified to the furthest extent. You can't go any further. Okay, I promise you, this is going to be the one that you go, it's prime, it's prime, it's prime. And I'm going to write difference of two squares over and over again until you see it. And it will take you some time. Okay, I promise you that. All right, you've got about 15 minutes to do your odds.